Welcome students. Today we are going to see a different topic from C++. Each and every programming languages has two fundamental elements. One is data type, another one is variables. The data types are used to handle the data schemes in any programming language. Without these two elements, we are not able to write any programs in any programming language. In each and every programming language, it may be C, C++, Java, .NET, whatever it is, it has three different types of data types. One is derived data type, second one is built-in data types, third one is user-defined data types. Under derived data types, four different data types are there. One is array, next one is function, third one is pointer, fourth one is reference. The built-in data type further divided into three types. One is integer type, second one is floating type, third one is void. The integer data type further divided into two types. One is int, another one is character. The floating data type is further divided into two. One is float, another one is double. There is no type in void because it doesn't return any value. Void, which is used to denote the generic pointer in any programming language. If you add void main in your program, you are not able to use return keyword in your program. That is what the fact. If you are using int in your program as the main function return type, you must use, it is not a mandatory, you have to use return keyword in your program. And next one is the types of user defined data types are structure, union, class and enumeration. These are all user defined data types because as your wish you can define or you can declare these data types. This is what various data types in C++. For each and every built-in data type, there is memory levels are there and ranges are there from which number to which number we can use. What is the memory level? If you are using int data type, what is the memory space occupied by that data type? That is what we are going to see from this chapter, from this session. So if you are seeing built-in data types, it further classified into three data types. One is integral type, second one is floating type, the third one is void type. There is no memory space for memory in terms of bytes. There is no memory space for void data type. For int data type, it occupies 2 bytes. In terms of bytes, it occupies 2 bytes. In terms of bits, it occupies 16 bits from the hard disk. And next one is character data type. In integral data type, the next one is character data type. The character data type occupies 1 byte in terms of memory. It occupies 1 byte memory space in terms of byte. In terms of bits, it occupies 8 bits. Next one is float data type. In in any programming language, float data type occupies 4 bytes. In terms of bytes, it occupies 4 bytes. In terms of bits, it occupies 32 bit. Double occupies 8 bytes. In terms of bytes, 8 bytes. In terms of bits, 64 bits. But while coming to C++ programming language, it varies for the compiler. If you are using dev C++ compiler, For integer data type, it occupies 4 bytes. If you are using Turbo C++ compiler, the integer data type occupies only 2 bytes. Let's go into the book. This is what known as variable. Before declaring the variable, for the variable you have to denote the data type. If you are not denoting the data type, it should return an error. In programming language, fields are referred as variables and the values are referred as data. This is what known as field. Name, age, average mark, these are all known as fields. These fields are referred as variables. RAM 1585.6, these are all known as values. These values are referred as data. Yes, so each and every data is different. This is string. The name field contains string as values. Age and average mark field contains numbers as values. But in the average mark, in the field average mark, it contains fractional values. Fractional value. So for these different variables, we have to give different data type. Because of giving strings as a value for name variable, we have to give data type as character here, CH. Next one is for age, we have to, because of using whole number as a value for age variable, here we have to give data type as int. For average mark, we have referred as fractional. We have given fractional value as value for average mark field, so that we have to denote data type as float here. This is how we have to give, or we have to declare data type variables in C++ programming language. And already I have explained you fundamental data types, which means the fundamental data type as well as known as built-in data type, because it is already predefinedly built in the compiler itself. Next one is user defined data types. The third one is derived data types. And next one, syntax for declaring variable. Before going to declare the variable, you should specify the data type, under which data type you are going to declare the variable. That is very important. To declare more than one variable which are the same data type, if you are using, between the variables it is enough to give semicolon, not semicolon, it is enough to give comma itself, not semicolon. If you are declaring more than one variable of the same data type, if you are declaring more than one variables of the same data type, between the variables it is enough to give comma itself to separate the variables. So see here, this is a single variable declaration. Int, the variable num1 is belongs to integer data type. This is what the same more than one variables of the same data type. So like that we have to declare. If you are going to declare more than one variable of the same data type, it should be separated by the comma. It should separated by the comma. Next one is introduction to fundamental data types. So fundamental data types further divided into three types. One is integral type, second one is floating point, the third one is void. So first one is integer. The integer data type always accepts and receives whole number only, integer numbers. If a variable declared as a int, C++ compiler allows storing only integer values into it. If you try to store a fractional value within integer data type, it will accept only integers portion and it will avoid the or ignore the fractional part portion. See here, for example, if you are giving int num, it will accept 12 and it will retrieve 12. Suppose if you are trying to give uh, instead of giving 12, if you are trying to give 12.5, it will accept only the integer part, it will ignore the fractional part. That is what they are trying to say here. Next one is character data type. It will accepts and returns all valid ASCII characters. Totally 127 ASCII characters are there. I mean, for C++ compiler, 127 or 253 ASCII characters are there. The character data type accepts all valid ASCII codes and it will return all valid ASCII characters. See here, CSAR. This is what syntax for declaring character data type, and C is variable, A is the value I have stored within the variable C. If you want to retrieve the value of C, you should retrieve like this. Here they have given a small program. I am going to run this program. So see here, first we have to open Turbo C++ compiler. After opening the compiler, this is the program I have typed already, and the purpose of this program is for clearing the size of operator. What is the use of size of operator? So see here, I have declared three different variables under three different data types. The first variable A is under integer data type, the second variable B is under float data type, the third one C is under double data type. Here I have retrieved the sum of these variables A plus B plus C, and next one is size of operator. I have used size of operator. What is the purpose of using size of operator? Is I can retrieve the memory space occupied by that data type, by the data type here. So here I am going to run my program. Value of A is 5, value of B is 9.894 and value of C is 9090. Here I am going to run. There is no error in my program. This is what sum of the program. See, size of A is 2. Already I have explained you the size of integer data type is 2. The size of float data type is 4. The size of double data type is 8. This is how we have to retrieve the size of data types with the help of size of data type, size of operator. So next one is open a new document, open a new prompt. So here I'm going to give hash include io stream iostream.h. Next one is hash include conio.h conio.h, and here I'm going to use void main. It doesn't return anything. Void, it doesn't return anything, which is used to point out a generic pointer. And here I'm going to give int n and char character a, and here I'm going to give cout enter a valid character chrac character of ASCII. And it should Here I am going to use cin, it should save in a, and here I am assigning the value of a is equal to n, and here I am going to give n is equal to a, and c out the ASCII ASCII VALUE ASCII value of given character is CHARACTE or character is equal to, here I am going to retrieve n. Here I have to open my program, sorry I forgot here, and here I have to give CLR SCR CLR SCR. Here I have to give get ch, and I have to close my program, and here I have to give, I can give from 0 to 255. So here I am going to first I am going to compile my program to check the errors. So there is no error, press any key, and I am going to compile, I'm going to run my program. So here I am going to give 100. So the value of ASCII value of 100 is 49. Here again I am going to give, see, again I am going to execute my program. So here I am going to give a 65. The ASCII value of a is 65, and the ASCII value of small a is 97. Small a is 97. This is how we have to declare character data type, and we have to get the value. Here with this line, with the help of this line only I am going to get the value for the character data type a. What is the value I am going to give from 0 to 255? That should be stored into a, and afterwards I am assigning the value of a is equal to n. Here what is the value I am getting with the help of this line? That should be assigned to n, and finally I am retrieving the ASCII value of the a with the help of n. Yes, so this is what the program they have given in your book, and we can give different programs for handling character data type. So see here, instead of giving too much variable, here I am going to give computer science. If you are giving a string, if you are giving sequence of characters within a variable, it should be given within double quotes. For example, a is equal to computer science. If you are giving a single character, if you are assigning a single character as value for any variable, that should given within single quote. Yes, so next one I am going to retrieve the values of a and b. A is equal to a, and ndl. ndl is, what is the purpose of giving ndl? To print the to print the output in the next line only we are giving ndl. So see here, again I am going to give C out. Here I am returning the value of B. For accessing the value B, I have to call B. Here no need to give NDL because there is no output statement. There is no output statement after accessing the value of B. HCH. So again I am going to give compile. Again I am going to compile my program. There is no error. I mean only one error is there. So char cannot convert char to char. It is not able to convert char to char. So here I am going to erase that one. So again I am going to compile my program. Errors, again the same error, it is showing the same error. So again compile it, no error. So I am going to run my program. So the value of A is A. This is how we have to declare the character data type and return the value from the variable. So next one is other data types we are going to see. So other data types here, float data type. So if a variable is declared as a float, all values will be stored as a floating point value. If you are declaring a variable as a float data type, it will store all the values as a fractional values. There are two advantages of using float data types. While using float data type, it may have two advantages. It can have two advantages. One is they can represent values between integers. Between the integers, they can represent a much greater range of values. Between the integers, they can represent the values, as well as it may represent much greater range of values. The range of values may be greater than integer data type. This is of example. This is what the example for float data type. This is how we have to declare the float data type. So if you are giving any fractional values within a variable, that should be known as float data type, float variable or float value. So next one is double. So double is also used to handling fractional part values, which means floating point values, but the precision after the decimal point, the precision occupies more than the float data type, which means after the dot, right side of the dot, I mean the numbers of right side of the dot will be more than that of float data type. Next one is void data type. So the literal meaning of void is empty string, empty space, which means it doesn't return anything, which is used to specify the generic pointer. Already I have explained you. So already I have explained you, if you used void as a return type for your program in your main function, you are not able to use return keyword. When you are going to use integer as your return type of your main class or main function, at that time you can use return keyword. if you have given only main, instead of giving int main or void main, if you have given only main, the default return type of your main function is integer. And next one is memory representation of fundamental data types. We are going to see, and see here, this is what memory representation for character 1 byte, in terms of bytes, in terms of bits 8 bits, for integer 2 bytes and 16 bits, for float 4 bytes 32 bits, for double 8 bytes and 64 bits. And next one is data type modifier. Because if we are using any keyword in front of data type, we should not modify the data types. So modifiers are used to modify the storing capacity of fundamental data type except void type. What is the use of using modifiers? Modifiers are used to modify the data type, storing, basic storing capacity of a fundamental data type. Because of using data type modifier, we can change the storing capacity of a fundamental data type. So the modifiers can be used to modify, expand or reduce the memory allocation of any fundamental data type. So 4 different modifiers are there. One is signed, next one is unsigned, long, short. Signed means negative numbers, unsigned means positive numbers. Long, which is used to expand the value, storing value of a data type. Short, which is used to reduce the storage capacity of a variable. Because of using short, space in memory of short is 2 bytes. Range of short, which is equal to int. See here, short int. The range of value of int is minus 32,768 to 32,767. From the range we can use any number. And next one is unsigned short. Unsigned short, signed means negative numbers, unsigned represents only positive numbers. It is also occupies 2 bytes. In terms of bits, 16 bits. The range of value is 0 to 65,535. Next one is signed short. Signed short, it is also equal to short int. It is also equal to short int. Here it is wrong. Here you have to change as 16 bit. 2 bytes means only 16 bits, not 32 bits. Both short and signed short are similar. There is no difference, because short is also handling 2 bytes, occupies 2 bytes and handling the same range of signed short. So next one is int. An integer may or may not be signed. It may signed number or unsigned number. Signed means negative number, unsigned means positive number, and it is also occupies 2 bytes and 16 bits. The range is minus 32,678 to 32,667. And next one is unsigned short, unsigned int. Unsigned means without any sign, minus symbol. It handles only positive numbers, not negative numbers. Signed short, it handles negative numbers as well as positive numbers. Next one is long. Long occupies 4 bytes, long double occupies 10 bytes. And in terms of bits, it occupies 32 bits. This is the range. From this range to this range we can give as a value for the long data type. And next one is unsigned long. It handles only positive numbers from 0 to this range, 4 crore 29 lakh. So this range. So next one is signed long. Signed long handles negative numbers as well as positive numbers. Signed long is also similar to long. There is no difference. So the above table clearly shows that an integer data type accepts only 2 bytes of data, whereas long int accepts 4 bytes. Long int accepts data that is double this size, which means 4 bytes. When you use long int, when you use long modifier, when you use long modifier in front of integer data type, it will expand the size of the normal int data type. So next one is character data type. So I already explained you, character data type occupies 1 byte. In terms of bits, 8 bit. The range is minus 128 to 127. Unsigned means from 0 to 255. Signed, it is also very similar to character data type. And next one is floating point, which means fractional values. Float data type occupies 4 bytes. In terms of bits, it occupies 32 bits. This is what the range of float data type. So you have to understand this concept. I mean, in terms of, space in memory, you have to understand and you have to keep these things in your mind. You have to keep these things in your mind for long term, for exam point of view. It may ask in 1 mark in your public examination, what is the space in memory of a float data type or double or long double. They will ask in public examinations. So for long, if you are using long double, it will occupy 10 bytes, which means 80 bits. For double data type, space in memory in terms of bytes 8 bit, in terms of bits 64 bits. But it may vary. I already explained you, it may vary, depends upon the compiler. See here, this is Turbo C++, this is Dev C++ compiler. For short, in Turbo C++ and Dev C++, occupies only 2 bytes, and signed short 2 bytes, signed short 2 bytes. But see here, for integer data type, int, unsigned int, signed int, Turbo C++ compiler occupies only 2 bytes, but Dev C++ compiler occupies 4 bytes. Other things are same, other data types are same, but long double in Turbo C++, long double data type accepts, occupies 10 bytes in space memory, but in Dev C++, the same data type long double occupies 12 bytes. That is the difference. So next one is number suffixes in C++. If your suffix the numbers L or U either in lowercase or uppercase, this type of declaration instructs the compiler to store the given value as long or unsigned. If you are giving 45L, the value L should be stored as a long value. If you are giving 45U, the value 45 will be stored as an unsigned value, which means positive number. F can be used for floating point values. For example, if you are giving 3.14 F, that should be stored as a floating point value. That should be stored as a floating point value. And next one is variable. Already I have explained you, it is user defined one. So it is also known as identifiers. Already I have taught while taught the first lesson of C++. Some rules are there for naming the variables. You should memorize those rules when you declare the variables. There are two values associated with a symbolic variable. They are R value and L value. In variables, R value is data stored in memory location. L value is the memory address in which the R value is stored. L value is nothing but it is memory address in which R value is stored. So see here, if you are giving num1 is equal to 65, it will occupy 4 bytes. It will occupy 4 bytes. This is 1 byte second byte, third byte, 4 byte, and this is what these are all r value. R value is nothing but what is the value I have assigned for the variable. These are all L value. L value is nothing but address of those memories. These are all address of those memories. Next one is declaration of variable. Each variable should be declared before they are actually used in program. Declaration is the process of instruct the compiler to allocate memory as per the type that is specified along with the variable name. Declaration is nothing but if you are declaring the variable along with the data type, that is what known as here declaration. So declaration, it is a process. What is the use of declaring a variable? It is the process to instruct the compiler to allocate memory space for the variable as per the data type. If I am using int a, if I am declaring a variable a under the data type int, I am instructing the compiler, I have declared a variable called a under the data type integer, so you should allocate memory space for the variable a as per the data type. That is what the declaration process. So here they have declared int num1 num2 sum. As per Dave C++ compiler, it occupies 4 bytes for num1, 4 bytes for num2, 4 bytes for sum. Totally for this data type integer, the compiler, Dave C++ compiler, allocate 12 bytes. If you are using Turbo C++ compiler, the Turbo C++ compiler will allocate only 6 bytes for this integer data type, because Turbo C++ compiler allocates only 2 bytes for integer data type. This is what memory address. This is what memory address for num1 and num2. And see here, they have declared int num1 num2 sum, but they never get the value for num1 and num2. So these type of variable declarations are called as junk or garbage values, because these memory space are going to be waste, because they never received input from the user for num1 and num2. So these spaces are going to be waste, so that these type of declarations are called junk or garbage values. But in Java, garbage collection is there. These unwanted or unused spaces will be collected and it will given to the compiler again. But C++ doesn't have garbage collection. Next one is initialization of values. Declaration of value is different and initialization of variable is different. If you are declaring int a, that is what declaration. If you are giving value, if you are assigning value to the variable, that is what called as initialization. The process is called as initialization. If you are assigning initial value to a variable during the declaration, this is what declaration part. If you are assigning the value during the declaration for a variable, that will be known as initialization. This is a small program and this is the output for this program. And next one is dynamic initialization. Dynamic initialization is nothing but if you are getting the input, if you are giving the input at the time of running time, at the time of execution, at the time of executing the program, that should be known as dynamic initialization. See here, a variable can be initialized during the execution of a time. It is known as dynamic initialization. See here, for the variable num1 and num2, if you are giving the variable at the time of execution, that is what known as dynamic initialization. And this one is also known as static initialization. If you are assigning values like this, you are not able to change the values at the time of execution, at the time of run the program. But if you are giving dynamic initialization for your program, you can change the value for each and every executing time. And next one is the access modifier constant. Constant is a keyword. Already I have explained you, it is a keyword, so that we are not able to use any keyword as a variable, so which is used to declare as a constant. So if you are, see here, if you are giving constant keyword in front of any variable, you are not able to change the value of the variable at the time of execution. So constant keyword modifies or restricts the accessibility of a variable. You are not able to change the value. See here, they have given constant keyword in front of num variable, but in this line they are trying to modify the value, but because of giving constant, it will never allows the user to change the value of constant variable. So for this I will give examples at the end of this session. So next one is references. A references provides an alias for previously defined variable. So for references we have to give ampersand symbol and symbol. For references we have to give ampersand symbol. So which means alias is nothing but it will provide a reference, it will provide a reference for previously defined variable. Declaration of a reference consists of base data type, base type and an ampersand symbol. So see here, this is what num, I am giving alias num, I am giving alias num temp, I am giving alias num, I am giving alias for num variable temp. So here declaration of a reference variable temp. Here I am giving temp as an alias. Here I am giving temp as an alias to the variable num. So in this place, because of giving alias temp to num, what is the value I have given for num, that should be taken by the alias, reference variable. If you are using ampersand symbol in front of any variable, that should be known as reference variable. So next one, formatting variable. Formatting variable is nothing but, if you are designing your output screen, that should be known as formatting variable. So NL, set W, set fill, set precision and set F, these are all comes under formatting output. So NL, which is used to print the output line in the next line. Set W, which is used to set the width in a predefined number. So see here, because of giving set W as 25, it should set the width after some space. See here, because of giving set W, the values has been printed as a same line, as in same part. This is what the usage of giving set W. So next one is set precision. This is used to display the numbers with fractions in a specific number of digits. If after dividing a number by another number, the fractions, the fractional parts will goes on as long as. So to avoid that, we can give set precision function. So see here, because of giving set precision, the fractional part number will be contained. Next one is fixed and scientific. In set precision, two different manipulators are there. One is fixed and fixed and scientific. These two different forms are there in set precision. One is fixed and another one is scientific. So these two forms are appropriately used before the set precision manipulator. See, if you are using fixed, it can be used as fixed like this. If you are using scientific, that is also used scientific like that. So see here, you can use like this. Next one is expressions. So I already explained you an expression is a combination of operators and operands. What are the variables I have assigned for the variables? What are the values I have assigned for the variables? That should be known as operand. So operators are nothing but the symbols are known as operators. And in C++ language, totally 7 different expressions are there. One is constant expression, integer expression, floating expression, relational expression, logical expression, bitwise expression, and pointer expression. So constant expression consists only constant values, which means at the time of execution we are not able to change the value. And next one is integer expression, is nothing but the combination of integer and character values. Both the things are combined within integer expression. Next one is float expression. If any float number, if any fractional numbers are within any expression, that should be known as float expression. Next one, if you are using any relational operators, if you are using any relational operators within an expression, that should be known as relational expression. Next one, if you are using any logical operators, double and symbol, double or symbol within an expression, that should be known as logical expression. And next one is bitwise expression, left bitwise and right bitwise. If you are using any bitwise operators, that should be known as bitwise expression. Pointer expression, if you are using star symbol in front of any variable, that should be known as pointer expression. So the star symbol which is used, or the star symbol which is used to declare a pointer variable. If you are declaring any pointer variable in your program, that should be declared with star symbol. So students, I hope you all understand. So only two concepts are there. And next one is type conversion. If you are converting the fundamental data type into another one, that is what called as type conversion. If you are converting the fundamental data type into another fundamental data type, that is what called as type conversion. There are two different types of conversions are there. One is implicit conversion, another one is explicit conversion. If the compiler automatically convert a fundamental data type into another fundamental data type, that should be known as implicit type conversion. If the user giving explicitly to type a fundamental data type into another one, that is what called as explicit type conversion. That should be known as explicit type conversion. This implicit type conversion is also known as type promotion. So see here they have given a is equal to 6 and b is equal to 3.14. So the variable a is declared under integer data type, the variable b is declared under float data type. But see the result, a plus b. The result is a plus b. So here one data type belongs to integer data type, another one belongs to float data type, but the result is which one has the highest range, or which one has the highest memory space in terms of bytes or bits. The answer would be converted to that type. This is here the implicit conversion is happened. Here the implicit conversion is happened because 6 point 6 plus 3.14 becomes 9.14, but here they didn't say which in which data type should be converted, so that it should convert which data type has the highest range or highest memory space. Among these two data type, float has the highest uh, space in memory, so that the result has been converted into float data type. This should be known as implicit type conversion, and this is called as type promotion. This is what the table can be converted into another fundamental data type. The character data type can be converted into character short int, and this is what possibilities conversion pattern. And next one is explicit conversion. Explicit conversion is nothing but if you are giving or if you are instructing the compiler from which data type to which data type has to be converted, that is what known as explicit type conversion. See here, the value of the variable is 78.685, but here I am instructing the compiler the value should be converted into integer data type. So students, next one is explicit conversion problem. Double to float, you are not able to convert the double data type into float data type because loss of precision. If the original value is out of range for the integer type, the result becomes undefined. So during the explicit conversion, if you assign a value to a type with a greater range, it does not cause any problem, but assigning a value larger type to smaller type may result in losing or lost precision values. So you are able to convert float to double easily, but it is very difficult to convert the double data type into float data type. So at the time of converting the double data type into float data type, loss of precision will be there, and it is also float to int, that is also loss of fractional part will be there. And next one, long to short, that when you convert long to short, and in that conversion also loss of data will be there, because long is a access modifier, it contains long value. When you are going to convert the long value into short, loss of data will be happen. So students, I hope you all understand these concepts very well. So for this, I am going to give some example programs. Before that, I will give the answers for the 1 mark book back. First one, how many categories of data types are available in C++? 3 types: user defined, derived data type, and next one is built-in data type. Which of the following data type is not a fundamental data type? So fundamental data type is not a fundamental data type, is signed. What will be the result of the following statement? Char ch is equal to b, int ch is equal to, so the char should be converted into int data type, so that 66 will be the answer. Which of the following character is used as suffix to indicate the floating point f? For fifth one, how many bytes of memory allocated for the following variable declaration if you are using dev C++? Short int x 4. And next one is, what is output of the following snippet? CH or character data type a is equal to a, and ch is equal to ch plus 1. So output will be b. Which of the following is not a data type modifier? Int is not a data type modifier, because other 3 things are comes under data modifier. Which of the following operator returns the size of the data type? Size of operator. Which operator is used to access reference of a variable? Ampersand symbol. This can be used alternate to endl command. Instead of using endl command, we can use this one. Here we have to change the option D. So students, I hope you all understand the concepts very well. Now I am going to give some small example programs for the finished session. Just see, I am going to open this one. And here as include stream.h as include conio.h. Here I am going to use main. If you are using only main, the default return type of your main function will be integer. So next one is int a is equal to 5 and float b is equal to 9.14. Finally, the output will be in float data type. This is what known as explicit conversion. Sorry, this is known as implicit conversion. If you are giving data type explicitly, that is known as explicit conversion. So next one, I am going to give CLR SCR for clearing the output screen, and now I am going to get the value of a plus b. A plus b is equal to, here I am going to give a plus b. Here I am going to use getch. The purpose of using getch is to stabilize your output screen. If you are not used getch function, your output screen will be come and blinked. That's all. So now I am going to run my program. Only one warning is there, function should return a value. So here I didn't use any return type in front of main. I have given as a empty one. So the default return type of this function is int. So now I am going to run my program. See, a plus b is equal to 14.14, but here one value comes under integer, one value comes under float, and here I didn't specify to the compiler from which data type to which data type converted. So the compiler itself change from one data type to another data type. This is what known as implicit conversion. So next one I am going to give cout within the bracket int b. So now I'm going to run my program. Yes, 9. Because of using integer data type, I am instructing the compiler the data type value, I mean the data type b value should be converted into integer data type. So integer only accepts the whole number value. So this is what the examples for those programs. So students, if you have any doubts, please make a note of it. After opening the school, we will clarify the doubts, I mean we will discuss the doubts. I hope you all understand the concepts very well. Thank you all.